Okay, so let's continue on with the trig identities and finish this up. Now, for every section, for the remaining sections of Chapter 8, just like with solving equations, every section there'll be some new solving equation problems and there'll be some new applying trig identity problems. So we're not done with the trig identities, but we're done with the bulk of them. Okay, so let's look at this guy. First sight, like, what the heck can I do here? Well, it's a fraction equal to a fraction, and we do know that that's a good way to start. So let's get started here. Hold on, I moved my setup a little bit, and everything's just a little bit off during the break. Okay, so I'm going to cross multiply. So we're going to have cosine theta times this guy, sine theta minus cosine theta plus 1, equal to our sine theta plus 1 times, I'll put that in a little square bracket so I'm a little bit more consistent there, times, because this one's going to get a little bit messy with all this multiplication. Sine theta plus cosine theta minus 1. All right, so I'm just going to distribute on this side here. So I'm going to have sine theta cosine theta minus cosine squared theta plus cosine theta equals to, and here on this side we're going to have to FOIL distribute it, right? So I'll get sine squared theta plus sine theta cosine theta minus the sine theta plus a sine theta plus a cosine theta minus 1. Okay, I'm going to write up here that we cross multiplied. That was our technique that we used here. Okay, now let's see what can happen here. Well, we've got a sine cosine on this side and a sine cosine on that side, so they cancel. We've got a negative sine theta and a sine theta here. Those cancel. And we've got a cosine on this side and a cosine on that side, so those cancel. So let's just see what we're left with. Negative cosine squared theta on this side, nothing else, equals, and here we're left with a sine squared theta minus 1. Now, you might recognize this as being true from the start. Okay, you might be able to see that this is equivalent to cosine squared theta equals 1 minus sine squared theta, but you might not see that. So I'm just going to go ahead and just divide out a negative. Or you could move the cosine over and the 1 over. There's a bunch of different ways that we could do this. But I'm going to wind up with cosine squared theta is equal to negative sine squared theta plus 1. And then I'm going to move that sine squared theta over just to be sure that this is true. Yay! Okay. Now I have 2 on this side, and I want this first one to kind of get your juices flowing. Let's throw you a little you-do. This is going to be a relatively short lecture. There's only 8 slides. So I'm going to start off with a you-do for you to think about. Now, I'm going to give you about a minute 30, and I'm going to give you a suggestion that you're going to start off by maybe factoring common factors out of each side and then seeing what you might be able to come up with that. Okay, so anytime you see secants and tangents that are raised to a power together, particularly even powers, you want to think, oh, I'm probably going to need to use that Pythagorean identity. So before I get started, I'm going to come down here and I'm going to have me a little think bubble because I don't have those memorized. Okay, and so I'm going to just shorthand here my sine plus cosine equals 1. This is sine squared plus cosine squared equals 1, but this is me shorthanding it. This is me showing you how to quickly get it. Now, we need tangents, and tangents are sine divided by cosine, so we're going to need to divide all these through by cosine, and that's going to give us a tangent squared theta plus 1 is equal to a secant squared theta. See how quick that was to just kind of knock it out? Okay, so I'm just going to put this on the side burner here, and I'm going to go back up here to the problem and start working on the problem. Now, looking at the left-hand side, I see that I can commonly take a secant squared theta out, and I will be left with a secant squared theta minus 1. And looking at the right-hand side, I could also take a tan squared theta out, and I could be left with a tan squared theta plus 1. Now we see down here that tan squared theta plus 1 is equal to secant squared theta. So this could be rewritten as secant squared theta. Okay, and tan squared theta itself, come down here and solve this for tan squared theta. And again, there's a whole bunch of different ways you could see this problem. You may have worked it a different way, and that's okay, but that is true as well. So I'm going to replace this guy with secant squared theta minus 1. And so now you can see that these guys are equal. Okay, cool. All right, so let's move on to this one. Now this one's a little right-hand side, left-hand side thing, because notice we don't have like a fraction equal to a fraction, but we do have these two fractions added together here. So I'm going to work with the left-hand side, which is 1 minus tan squared theta over 1 plus tan squared theta. And that fraction is added to 1. So I'm going to put these guys together. I'm going to multiply this this side by the LCD, which is 1 plus the tan squared over 1 plus tan squared. Okay, so then that gives us 1 minus tan squared theta plus 1 plus tan squared theta, and all that is over a single 1 plus tan squared theta, which is the common denominator. Now if we look up here at the top, these tan squared thetas, they cancel out. Awesome. And so then we're left with 2 over 1 plus tan squared theta. Now, that is now equal to 2 cosine theta, but what else is 1 plus tan squared theta? 1 plus tan squared theta is equal to secant squared theta. So this is going to give us a 2 over our secant squared theta, which secant is 1 over cosine, so that is equal to 2 cosine squared theta. Now, I almost lost some faith while I was going along there for a second. Did you? I really did right there at the end. I was like, what's going on with that 1 plus tan squared theta? And then I was like, oh, wait. That is the secant. Okay, let's keep on going. Alrighty, let's take a look at this one now. Clearly, we're going to have to do some left-hand side work. There's nothing to do on the right-hand side. We can't simplify that any more than it just being sine v plus cosine v. So let's get over here. And the first thing I kind of notice is I could separate this left-hand side. So I'm going to look at this left-hand side and I'm going to separate it. It's going to become secant squared v over secant v minus tan squared v over secant v plus tan v over secant v. Okay, so this turns into just secant v minus, now tan is sine over cosine and secant is 1 over cosine. So this is sine v over cosine v over 1 over cosine v. And this stuff here is squared. And then we have the exact same thing. Sine v over cosine v. All that crap is over 1 over cosine v. Now let's just work with these couple of pieces here. When we simplify this, we get to state change flip, so we get to flip this over. So we'll be left with sine squared v over 1 cosine v minus our secant v. I'm just going to write it here. We'll probably change it here in a minute. And then this guy becomes just plus sine v. Now let's keep on going here. Secant is 1 over cosine. Yeah, that's how we're going here. So 1 over cosine of v minus sine squared v over cosine v plus our sine v, and I'm going to multiply it by cosine v on top and bottom so we can put it together. What I did here is just the old cosine v over cosine v. Sorry, I got a frog in my throat. I hope it croaks. So bring this up here. Now, because the denominators are all the same, we can put the numerator together in one cohesive thought here. And it's all over cosine v. Well, I think at this point, we're going to go ahead and be like, is it equal to, that's about as straight as I can get it, is it equal to this guy, sine v cosine v? So we can do a little cross multiplication here. This is over 1, right? So we'll wind up with 1 minus sine square v plus sine v cosine v equal to cosine V times sine V plus cosine V. All right, let's see what comes out of that. Let me just write this down again. Now let's multiply this through. So this is a sine V cosine V plus a cosine squared V. Oh, this is looking so good in the hood now. Wasn't looking good for a while. It looked like it was getting messier and messier, but look at those. Those are the same, so they're going to cancel. And my, look what we have. 1 minus sine squared V is equal to cosine squared V. And we've done this a few times. Move that sign over. We've got 1 is equal to sine squared V plus cosine squared V. And that is a true statement. Yay. Oh, excuse me. I got the worst frog in my throat. Okay. So, I'm going to give you a couple minutes to work on this one, you do style. Now, there are definitely a couple of ways to work this guy. So I want to give you some time to work on it, and then I will jump in and probably do it differently than you tried to work on it. So let me give you about a minute, minute and a half to get going on this. Now, if you haven't finished, please feel free to pause, but let's go ahead and jump in this one now. I'm gonna guess that most of you tried to solve this like the last problem and multiplied that 1 by 1 minus cosine theta over 1 minus cosine theta, and then try to do something with that side of the equation. But what I noticed is this and this. This is 1 minus cosine theta is a factor of 1 minus cosine squared theta. And I noticed this sine squared and I was like, ooh, I can use the Pythagorean identity here. Remember, we have our sine plus cosine equals 1. So that means our sine squared is equal to 1 minus the cosine squared. And that's the difference of two squares. So that's the first step here. So we're going to have 1 minus, and I'm going to turn this into 1 minus cosine squared theta over this 1 minus cosine theta. And again, remember, you can't just cancel these guys one for one. This you have to factor as the difference in squares. 1 minus cosine theta, 1 plus cosine theta, all over 1 minus cosine theta. And you see, oh, look at that. It's so pretty. So now you wind up with 1 minus 1 plus cosine theta on this left-hand side. And let's clean that up. That's 1 minus 1 minus cosine theta, which is, these guys cancel, of course. 1 minus 1 is 0. And so we're left with negative cosine theta. Yay! Okay, let's keep on going. All right, so strap in. Got to stay focused on a problem like this one. Okay, it's just an exercise in your algebra skills. That is all that's going on here. So let's get started. Now, I'm going to just work with that left-hand side, of course. Not anything I can do on the right-hand side. So I'm going to square out our a sine theta plus b cosine theta. I'm going to square that out. That's going to be a squared sine squared theta plus 2ab sine theta cosine theta plus b squared cosine squared theta. Now, if you don't know any tricks on how to square up things like this, start practicing. Okay? Remember that the trick is it's the first thing squared plus 2 times the product of the two things plus the last thing squared. All right? So plus, it's one big fat stinking plus in between here, and then we'll get started with this one. So like I said, it's the first term squared, so that would be a squared cosine squared theta. In this case, it's going to be a minus because we follow the sign, and it's going to be 2 times the first term times the second term, so AB sine theta cosine theta plus, because it's always plus, the last term squared, B squared sine squared theta. Okay, cool. Now let's clean it all up. Okay, here, what do we got here? Well, we have a 2ab sine theta cosine theta and a negative 2ab sine theta cosine theta, so let's go ahead and get rid of those and kind of knock that noise down. And then let's rewrite this and see what we've got here. We've got a squared sine squared theta. And I'm going to put the sines together and then the cosines together. Plus b squared sine squared theta plus a squared cosine squared theta plus b squared sine squared theta. I mean cosine squared theta. Where does I lost my brain? My brain just went. So you can get lost in this pretty well. Cosine squared theta. Okay. So let's see. I'm gonna factor out a sine squared theta out of this side, and that'll leave me with an a squared plus b squared. And then I'm going to factor out a cosine squared theta here, and that's going to leave me with an a squared plus b squared. And now we could factor an a squared plus b squared out of this whole darn thing. Right, and we'd be left with sine squared theta plus cosine squared theta. And that stuff equals 1. So we get a squared plus b squared. It just tickles me. Okay. Let's see. Let me do one more, and then I'll have one last you do to do, and we'll be done. Okay, this one should look just as ugly. It is terribly ugly. It looks horrible. Like, what in the heck are we going to do with this thing other than just lean in and start foiling? Let me make sure I did write it down right, because it looks a little bit weird. Nope. Okay. It's all those extra parentheses. And I know I always put parentheses around my argument. And when you get further on in your math, you'll understand why I'm very careful about that. So anyway, I'm not defending it. I'm just saying that's how I roll. That's how I'm going to roll. Okay, so it looks like there's these two that need to be multiplied together to see through all the noise, and there's these two that need to be multiplied together. So let's get started here. So we can get started with tan alpha minus tan alpha cotan alpha cotan beta. So I've taken this first guy to both things there. Now let's pick up in the middle here. So this is going to be plus tan beta. This is one of those problems when you work on it, you probably want to turn your piece of paper sideways so you can get it all on one line. It'll make it much easier. So working on some like clean computer paper and turning it sideways will be really helpful here. Okay, so I got those. Now we got tan beta times 1 minus, and now we have tan beta. So I'm going to, tan beta, cotan alpha, cotan beta. Okay, that's all of that guy. Now let me do the next piece. Plus, and here we go, cotan alpha. Cotan alpha times negative tan alpha. Tan beta is negative cotan alpha. Tan alpha, tan beta. And then plus cotan beta. I gotta think thin on this right, and minus cotan beta, tan alpha, tan beta. I'm sorry I had to fit it all in there. Oh, I was too wasteful with my space over here. Okay, so now the cool thing about this is some cool stuff is happening. Now you have to be very mindful for the angle, okay? But remember, tan times cotan of the same angle, they cancel each other out and they're equal to 1 because one is sine over cosine, the other one is cosine over sine. So right here, these two cancel each other out, leaving just that cotan b. Here we have tan b and cotan b. Angles are the same, they cancel out. Just a cotan. Here we have cotan alpha and tan alpha, so they're going to cancel each other out. And here, here we have just a stray mark that I made. And here we have cotan beta and tan beta. You can't tell because it's terrible, but there we have it. All right, so let's see what we're left with. I'm going to change colors altogether. So tan alpha. This piece leaves us a minus cotan beta plus a tan beta minus a cotan alpha plus a cotan alpha minus a tan beta plus a cotan beta minus a tan alpha. All right, let's see what we have here. I'm getting my, let's see, we have tan alpha and a minus tan alpha. We got a cotan beta and a minus cotan beta. We got a tan beta and a minus tan beta. We got a cotan alpha and a minus cotan alpha. Look at that crap. Equals 0. Awesome. Okay. Last one. And I'm going to leave it to you to do. And we're going to take about, I don't know, 2 minutes because it's a lot of foiling. So let you work on this. You do it up. I'll give you 2 minutes, then I'll come back and start busting out that algebra. Okay, so for this problem, I'm just going to start with this left-hand side and just see if we can just make it look like the right-hand side or something. So first I'm going to square this off. So it's going to be the first term squared plus the product of the two middle terms. So 2 sine alpha cosine beta plus the last term squared, cosine squared beta. And then these need to be FOILed. So plus whatever this business is. So this is going to be a cosine squared beta minus a sine beta cosine, or sine theta. Oh, that is a fail. Let me see what that is supposed to be. That should be an alpha. Let's fix that. Okay, sorry. So that's going to be, where was I? Sorry, cosine. So sine alpha cosine beta. Lost where I was. Then we pick up there with the sine alpha, so we have a plus sine alpha cosine beta minus a sine alpha squared. Which, by the way, I could have recognized that this was the difference of squares, but I didn't because I got sidetracked by having that typo. But anyway, okay, here we are. We're back. Okay, let's see. What can we do here? So here is a negative sine squared theta, sine squared alpha, and here's a positive sine squared alpha. We can get rid of those because they're on the same side of the fence. Here's a sine alpha cosine beta and a negative, so those cancel. What are we left with? Looks like we're left with, let's see, we're left with these two guys, so that's 2 cosine squared beta, and we're left with plus a 2 sine alpha cosine beta, and if we factor a 2 cosine beta out of here, then we're left with cosine beta plus sine alpha, which is absolutely equal to 2 cosine beta times sine alpha plus cosine beta. All right, so get it done. Y'all have a good day.